What is the diameter of a 1 meter length of tungsten wire whose resistance is 0.32 ohms? Right, we're going to start from two formulas here. So formula number one that we're interested in is resistance, R, is equal to the coefficient of resistivity for the particular material times the length of the wire over cross-sectional area. So rho L over A. Our second equation here that we need is the ratio between an area and diameter of a circle, and that is area is equal to pi times diameter divided by 2 squared, so pi r squared basically. And we're going to call this equation 1, and we are going to call this equation 2. Now, we are going to substitute equation 2 into equation 1 and rearrange. So this is going to give us that, so firstly, R is equal to rho L over pi d over 2 squared. And rearranging, we get that the diameter is equal to 2 square root of, so we multiply out by d over 2 squared, divide by r, square root both sides, multiply by 2 is the idea here. So because we have to find the diameter, so it's easier to make this the subject of the equation and doing lots of calculations and making numerical errors. Ideally, my advice is when solving problems like this that involve real numbers is to do all the algebra first and then just plug in the numbers at the end, because then even if you make a mistake, you get full marks for method, and that's important. Over pi r here. So we have diameter is equal to 2 times the square root of coefficient of resistivity for tungsten, and length of the wire, over pi times the resistance of the material. So what are our constants in this case? Well, we have L equals 1 from the question, pi is pi, and R is 0.322 ohms. So what we're missing here and what we need is the coefficient of tungsten resistivity, and we have rho tung for tungsten, because I'm marginally lazy and it's quite a long word, is equal to 5.6 times 10 to the minus 8. And substituting in these three values into this square root here gives us diameter is equal to 4.72 times 10 to the minus 4 meters. And if we, and to two significant figures, which is what the book gives it, is 4.7 times 10 to the minus 4 meters. And that's the answer.